This is the OCR GCSE 9-1 Maths Paper 6 from the June 2019 series, and it's from the higher tier, and it's a calculation. Question number 1. A grain of salt weighs 6.48 times 10 to the minus 5 kilograms on average. A packet contains 0.35 kilograms of salt. For part A, we have to use this information to calculate the number of grains of salt in the packet. Well, to do this, we need to find out how many grains of salt go into a packet, and this can be done by the following. We have 0.35 kilograms divided by 6.48 times by 10 to the minus 5 kilograms, and therefore if we work this out, we have 0.35 divided by 6.48 times 10 to the minus 5. It turns out here we get 5,401.234, etc. And therefore, for the number of grains of salt, we can round this number down. We have 5,401. And for part B, we have to explain why your answer to part A is unlikely to be the actual number of grains of salt in the packet. Well, each grain of salt can vary in weight or size or anything like that. So, because of that, the actual number in each packet may be different. Question number 2. Tom researches the weight of plant seeds. One poppy seed weighs 3 times 10 to the minus 4 grams. 250 pumpkin seeds weigh 21 grams. And one sesame seed weighs 3.64 times 10 to the minus 6 kilograms. We have to write the three types of seed in order according to the weight of one seed. Write the lightest type of seed first. You must show how you decide. Well, here you can see we've got grams, here we've got grams, here we've got kilograms. So we can get the units the same. To go from kilograms to grams, we would have to times by 1,000, and to go from grams to kilograms, we would have to divide by 1,000. So if we take a look at each of these different values, well, we've got the 3 times by 10 to the minus 4 grams, we'll leave that alone for a second. And then we've got the 21 grams, we'll leave that alone for a second. And then we've got this 3.64 times 10 to the minus 6 kilograms. And to convert this into grams, we would have to multiply by 1,000. So we have 3.64 times 10 to the minus 6. And if we multiply this by 1,000, we get 3.64 times 10 to the minus 3. Now, we've got everything in grams so far. And what we can do with the 21 grams is write that in standard form. Just as a reminder of how we write numbers in standard form, that's when we have a times by 10 to the power of n, where a is in between 1 and 10. So to write this 21 grams into standard form, we can divide by 10. So we've got 2.1 times 10 to the minus 1. And therefore, if we compare the powers of 10, you can see the smallest is the one with the most negative power. So this is the smallest, followed by this, followed by this. And so therefore, the lightest will be this first one here, the poppy seed, followed by this one, which corresponds to the sesame seed, followed by this one, the pumpkin seed. So these are the order of the seeds, with the lightest first. For question 3 part A, this spinner has 2 grey sections, as we see here, 2 white sections and 1 black section. The lad says the probability of the spinner landing on black is 1/5, and we have to explain why that is not correct. Well, if we think about the angle that black corresponds to, if we grab our protractor, we have an angle of around 26. So this angle is around 26 degrees. Now, if we had 1/5, 1/5 would correspond to an angle, well, of course, if we think about equivalent angles, then out of 360, because we've got angles around a point, what's equivalent to 1/5, that will be 72. So therefore, a fifth would correspond to an angle of 72 degrees. And what we found here is we've got 26 degrees. And therefore, you can see that is incorrect. Now for part B, the graph shows the cost of a litre of petrol for the last 6 months of 2017. So that's what we see in this graph. And we have to explain why the graph is misleading. Well, one reason is if we take a look at the axis over here, you can see that it does not start at 0. So one reason why the graph is misleading is it does not start at 0. Question number 4. Sophie is organising a raffle. Each raffle ticket costs 50p. She sells 400 tickets. The probability that a ticket chosen at random wins a prize is 0.1. Each winning ticket receives a prize worth £3. Sophie says, I expect the raffle to make over £100 profit. Show that Sophie is wrong. Well, first thing we can do is recognise that if she sells 400 tickets and each ticket costs 50p, she would sell in total 50p, which is 0.50 pounds, times by 400. So she sells £200 worth of tickets. Now, if the probability of winning a prize is 0.1, then the number of winning tickets, we would have 400 multiplied by 0.1, which is 40. So 40 people win, and therefore, if 40 people win, she would have to pay out 40 times by £3, So she would have to pay out £120. So if she sells £200 worth of tickets and she's paying out £120, then the profit, this is equal to 200 take away 120, which is 80. And because this does not equal the £100 that she is talking about, we can therefore conclude that Sophie is wrong. Question number 5. ABC is a right angle triangle with AB equaling 20 centimeters and BC equaling 37 centimeters. We have to calculate the angle BAC. So we would have to calculate this angle over here. We'll call it alpha. So what we've been given is the opposite. We've been given the adjacent. What connects the opposite to adjacent is tan. So we've got tan alpha equals the opposite, which is 37, over the adjacent, which is 20. And therefore, alpha, if we work out what this is, we have the inverse tangent of 37 over 20. You'd find this to equal 61.606, etc. And therefore, if we round our answer to a suitable degree of accuracy, we have 61.6 degrees given to 1 decimal place. Question number 6. A bag contains some counters. There's 300 counters in the bag. There are only red, white and blue counters in the bag. The probability of picking a blue counter is 23 over 50. The ratio of red counters to white counters is 2 to 1. We have to calculate the number of red counters in the bag. So the way to approach this is, well, the probability of picking a blue, we were told this is 23 over 50. And if we know that there are 300 counters in the bag to begin with, we can use this to determine the number of blue counters we have. Of course, to go from 300 to 50, we would have to divide by 6, and therefore, if we multiply by 6 here, then 23 times 6, that's 138. So therefore, the probability of picking a blue is 138 out of 300, and of course 138 out of 300 simplifies to 23 over 50. So therefore, there's 138 blue counters. Now, we were told that the ratio of red counters to white counters is 2 to 1. So, with this we can find out the number of red and white. So the number of red and white, that's equal to the 300 in total, take away the 138 which are blue. So 300 take away 138, that's 162. So we have 162 counters which are both red and white. And we're splitting this 162 into the ratio 2 to 1. So if we split this up into the ratio 2 to 1, well, from here you can see then we have 2 plus 1, which is equal to 3 parts, and therefore 162 divided by 3, if we work this out, we get 54 per part. And therefore, to find out the number of red counters we have is 2, because we've got 2 parts for red, multiplied by 54, so here we get 108. We have 108 red counters in the bag. Question number 7. We have to construct the perpendicular from the point P to the line AB. Show all of your construction lines. Well, with our compass, if we intersect the line AB like so, well, we want to intersect the line at 2 points, so we can intersect here, and we can also intersect here. And now that we've determined the intersection points, we can find the perpendicular to this. So put one of your sharp bits of the compass here, and then draw an arc like so, and keeping the same distance from here to here, put the other pointy bit here, and then mark off like that. So then if we join these up with a ruler, what we'd have is our perpendicular bisector from the point P to this line. So here you can see we would have indeed our 90 degrees. Question number 8. The graph shows 2 parallel lines, line A and line B. Line A has equation y equals 6x plus 7, and line B passes through the point 426, and we have to find the equation of line LB. So, if the lines are parallel, the gradient of B is equal to the gradient of A, which is 6. Of course, line A is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So knowing that the gradient is 6, we also know it passes through the point 426, and therefore we have y minus y1, so we've got y minus 26 equals 6 lots of x minus x1, so we've got x minus 4. And if we attempt to tidy this up, we have y minus 26 equals 6x minus 24, and if we add 26 to both sides, you can see y is equal to 6x plus 2. So we have y equals 6x plus 2 as the equation of the line B. Question number 9. Martha's solution to the inequality 8x plus 5 being less than or equal to 3x minus 10 is shown on the number line. Is her solution correct? Explain your reasoning. Well, we begin with the 8x plus 5 being less than or equal to 3x minus 10. And if we take 3x from both sides, you can see that 5x plus 5 is less than or equal to minus 10. And if we subtract 5 from both sides, 5x is less than or equal to minus 15, from which we can see x is less than or equal to minus 3. So we've got here x is less than or equal to minus 3, and what her number line is showing is x being greater or equal to minus 3. She's got the fact that we use a filled hole when we've got a weak inequality symbol, but the arrow is going in the wrong direction. So therefore, she is incorrect. She has shown x being greater or equal to minus 3 on the number line. Question number 10. In 2017, the value of a house increased by 4%. In 2018, the value of the house decreased then by 3%. Teresa says over the 2 years, the value of the house increased by exactly 1% because 4 take away 3 is 1. Show that she is wrong. Well, if we've got our original amount, then if we increase by 4% in 2017, we multiply by 1.04. So this comes from the fact that we increase by 4% in 2017. And then in 2018, the value of the house decreased by 3%, so we multiply here by 0.97. So this comes from the fact that we decrease then by 3%. So therefore, if we attempt to tidy this up, this tells us how much we have increased by. We've got 1.04 times by 0.97, which is 1.0088. So therefore, what you can see then is overall, if we work out what that is as a percentage, you can see we've increased by 0.88% overall. So therefore, we have an increase of 0.88% overall. Question number 11. You are given that 270 is equal to 3 cubed times 2 times by 5, and you're given that 177,147 is equal to 3 to the 11. We have to find the lowest common multiple of 270 and 177,147. Give your answer using power notation and as an ordinary number. Well, first of all, we've got 270, which is equal to 3 cubed, so we've got 3 times 3 times 3 times 2 times 5. And then we've got 177,147 equaling 3 to the 11. So we've got 3 multiplied by itself 11 times. So we're timesing 3 by itself 11 times, and with this we can find out the lowest common multiple. Well, we've got 3 over here, so let's just write this down. The lowest common multiple then is equal to 3, and then we've got this 3 over here, and then we've got this 3 over here, and then we've got this 2, and then we've got this 5 over here, and then we've got 1, 2, 3, 4, 5, 6, 7, 8 threes as well. So here we've got 3 to the power of 8. So therefore, what you can see then is we've got 3 to the power of 8, and then we've got another extra 3, so that will be 3 to the 11, and then we've got 2, and then we've got the 5. So therefore, we end up with 2 times by 3 to the 11 times by 5, and if we work out the value of this, we've got 3 to the 11 times by 10, which is 177,1470 as an ordinary number. And now we have to write 177,147, and then we've got here 6 zeros as a product of its prime factors. Well, what we can do over here is split this number up as the following. We've got 177,147 over here, and then here we've got 1, 2, 3, 4, 5, 6 zeros. So here we'd have 100,000. That we'd have here we'd have a million instead. So these are two numbers which multiply to give this value here. Now this over here, we've just worked out to be, well, we were told that this is equal to 2 times by, rather here we've got just here, this is just the same as 3 to the power of 11. And now we need to further split this up. Well, we can further split this up as 1,000 times by 1,000. And then the 1,000 we can further split up into 10 times by 100. And same over here, we can split this as 10 times by 100. Instead, what might be easier is recognizing that this value here is the same as 10 to the power of 6. Now 10 to the power of 6, this is the same as 2 times by 5 to the power of 6. So 10 is the same as 2 times by 5, and we're raising this to the power of 6. And therefore, using the laws of indices, this is the same as 2 to the 6 times by 5 to the 6. And therefore, we've got here 2 to the power of 6 times by 3 to the power of 11 times by 5 to the power of 6. So this is how we write this number as a product of its prime factors. And now, for part B, we've given that 3 to the n is equal to 177,147 times 9 to the 5. We have to find the value of n. Well, we've got here 3 to the n, and the value over here, we know that this over here is the same as 10 to the 11. So this value here is the same as 10 to the 11. And then we're multiplying this by 9 to the power of 5. Well, what we can do is get the bases the same. We have 3 to the n equaling 3 to the 11 times by 3 squared. So 3 squared is the same as 9. And then we're raising this to the power of 5. So we've got 3 to the n equals 3 to the 11 times by 3 to the 2 times by 5, which is 10. And if we add the powers, because we've got the same base and we're timesing, we have 3 to the n equaling 3 to the power of 11 plus 10, which is 21. And therefore n is equal to 21. Question number 12. Antonio rolls 2 fair 6-sided dice and calculates the difference between the scores. For example, if the two scores are 2 and 5 or 5 and 2, then the difference is 3. And we have to complete the sample space diagram to show the possible outcomes for Antonio's dice roll. Well, here we've got 2 take 1, which is 1. Then we've got 3 take 1, which is 2. 4 take 1, which is 3. 5 take 1, that's 4. 6 take 1, that's 5. And then we've got here 2 take 1, which is 1. 2 take 2, that's 0. 2. Then we've got 3 take 2, which is 1. 4 take 2, which is 2. And then we've got 6 take 2, which is 4. And then we've got 3 take 1, which is 2. 3 take away 3, which is 0. 4 take 3, which is 1. 5 take 3, which is 2. 6 take 3, which is 3. And then we've got 4 take 1, which is 3. 4 take 2, which is 2. 4 take 3, which is 1. 4 take 4 is 0. 5 take 4, that's 1. 6 take 4, that's 2. And then we've got 5 take 1, which is 4. 5 take 3, which is 2. 5 take 4, which is 1. 5 take 5 is 0. And 6 take 5, that's 1. Then we've got 6 take 1, which is 5. 6 take 2, that's 4. 6 take 3, that's 3. 6 take 4, that's 2. 6 take 5, that's 1. and 6 takes 6, that's 0. So here is our completed sample space diagram. And now for part B, Antonio rolls the dice. He rolls the 2 dice 3 times. We have to calculate the probability that we will get a difference of 1 on all 3 rolls. Well, over here you can see there's 6 times by 6, which is 36 different outcomes. So let's just write this down. So from the sample space there's 36 different outcomes. Now we have to find the probability that it gets a difference of 1 on all 3 rolls. So the number of different ways we've got 1, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different ways of getting a 1. So let's just write that down. So there's 10 different ways to get 1, and therefore the probability of getting a difference of 1 on 3 rolls, well, on one of the rolls the probability will be 10 out of 36, and because we've got 3 rolls we'd have to cube this amount. So we're cubing because we've got 3 rolls. And if we work this out on our calculator, 10 divided by 36, and then cubing this, we get a value of 125 over 5832. So this here is our probability. We've got 125 over 5832. Question number 13, we have to prove that the mean of any 4 consecutive even integers is an integer. Well, what we will do is we will let the consecutive integers be, well, if we've got even consecutive integers, we've got 2x, then we've got 2x plus 2, 2x plus 4, and then 2x plus 6. And we want to find the mean of this. So for the mean, this is equal to, if we grab a ruler, we have here 2x plus 2x plus 2 plus 2x plus 4 plus the 2x plus 6. And then we will divide this by 4. So what you can see here then, what we have is 2x plus 2x, that's 4x, plus another 2, that's 6, and plus another 2, that's 8. So we've got 8x, and then we've got 2 plus 4 plus 6, that's 12. So we've got 8x plus 12 over 4, which if we simplify all of this, it turns out we get 2x plus 3, which is an integer. So this here is an integer. And that's of course assuming here that x belongs to a set of integers. Question number 14. The length of the longest diagonal of a cube is 25 centimeters, and we have to calculate the total surface area of the cube. So first of all, let's draw a cube. So over here we have a cube. Now we were told that the length of the longest diagonal of the cube is 25 centimeters. So here is the longest diagonal, and the length of this is 25. So we've got 25 here. Now if we say that the length of each side of the cube is x, so we've got x here, here, and here, well, what we'll do is we'll further split this up using Pythagoras. So we've got this diagonal here, and we've got this diagonal over here too. So if we were to draw this out once again, we've got this length, and then we've got this length, and then we've got this over here. So if we add the dimensions on, we've got 25 over here, and here is x. And the length of this over here, well, again, if we use Pythagoras to help us find out that length, so if we use Pythagoras to split this up, what we have, if we split that up, is the following. So then we've got this. So here you can see we've got a length of x. Here we've also got a length of x, and therefore this length here will be x squared plus x squared square rooted. So through Pythagoras we have x squared plus x squared square rooted, so we've got root 2 x. And just to clarify how we got that, we've got 2x squared square rooted, which is the same as root 2 x, because square root of x squared is just x. So what we're saying over here is we've got root 2 x squared. Rather, we've just got root 2x over here for this length. So this length over here is root 2 x. So now, using Pythagoras, we've got root 2x all squared plus this x squared. This is equal to 25 squared. So root 2x all squared, if we square this, we end up with 2x squared, and then we've got another x squared. This is equal to 625. Now from here you can see that the surface area is given by 6x squared. And if we tidy this up, you can see we've got 3x squared equals 625. And if you compare what we have here with what we have here, well, you can see 3x squared is equal to 625, and therefore to go from the 3x squared to the 6x squared, we times by 2, and therefore we've got here 625 times by 2, which is 1250. So again here we times this by 2 to help us get this value here, and that's because we know what 3x squared is. We're finding out what 6x squared is, so we times by 2 to get this value here, and therefore the surface area is equal to 1250 centimeters squared. Question number 15, we have to solve by factorization. 5x squared plus 7x plus 2 equals 0. Well, what we can do here is, first of all, find two numbers which multiply to give 5 times by 2, which is 10, and which add to give 7. Of course, those two numbers are 5 and 2. So we can rewrite the 7x in terms of what we've found here. So in other words, we have 5x squared plus 5x plus 2x plus 2 equals 0. And of course the 5x plus the 2x gives us the 7x. And if we split this into two parts and factorize this first bit, well, you can see we've got 5x on the outside, and inside we'd have an x plus 1. We want an x plus 1 here, and you'd find x plus 1 lots of positive 2 gives 2x plus 2. and this is equal to 0. And if we group the terms together, we've got the 5x plus 2. So we've got 5x plus the 2. And this is being multiplied by the x plus 1. And this, of course, is equal to 0. So if we attempt to solve, well, either 5x plus 2 is equal to 0, or we've got x plus 1 equaling 0, from which we can see x is equal to minus 2/5, or x is equal to minus 1. And therefore, our solutions, we've got x equals minus 2/5, or x equals minus 1. Question number 16, we have to sketch the graph of y equals minus sine x, where x is in between 0 and 360. Well, if we were to sketch the graph of sine x, well, it starts off at 0. We've got a maximum at 91 over here somewhere. Then we go back down to 0. And here we go back to minus 1. And then we go back up to 360. So let's join this up with a smooth curve. So here, what you can see is we've got the graph of sine x. And what you should hopefully recognize, going from y equals sine x to y equals minus sine x, in terms of a transformation, we have a reflection in the x-axis. So here, we've got a reflection in the x-axis. So what we need to do is take this graph and reflect it in the x-axis. So if we do that, reflecting in the x-axis, well, what we'll do is we'll take each part separately. So this is reflected in the x-axis, like so. And then this over here is reflected in the x-axis, like so. And therefore here we've got the graph of y equals minus sine x. Question number 17. T is a radar tower and A and B are two aircrafts. At 3 p.m. aircraft A is 3250 kilometers from T on a bearing of 15 degrees. So if we draw a line from here to here, then here you can see we've got a bearing of 15 degrees. So we've got 15 degrees here as our bearing. Remember, with bearings we measure from north clockwise. And aircraft B is 4960 kilometers from T on a bearing of 057 degrees. So from here to here, we would have a angle of 57. And what we were told is here we've got 3250 kilometers, and here we've got 4960 kilometers. And for part A, aircraft A flies directly towards Tower T at a speed of 890 kilometers per hour. At what time will the aircraft pass over Tower T? Give your answer to the nearest minute. Well, over here for part A, what we need to do is use the fact that speed equals distance over time. So we've got speed equals distance over time. We've been given a speed, we've been given a distance, so we can find time. So the time it takes for A to go to T, so A to T, the time here is equal to the distance, which is 3250 3250 kilometers, and the speed, that's 890 kilometers per hour. So therefore, dividing these, 3250 divided by 890, you'd find here we get 3.651, etc. hours. Now, to go from hours to minutes, we need to multiply by 60, and minutes to hours we'd have to divide by 60. So if we work out what the 0.651 etc. is in minutes, so if I take 3, I times this by 60, and it turns out we get over here 3 hours and 39 minutes. So from 3 p.m. we're adding on 3 hours 39 minutes. So we've got 3 p.m. plus 3 hours 39 minutes. We get 6 p.m. and 39 minutes. So therefore the time will be 6:39 p.m. Now for part B, we have to calculate the distance that was between aircraft A and aircraft B at 3 p.m. So what we're doing in this question is finding out the distance between A and B over here. And for us to do this, what we need is this angle over here. Well, this angle will equal, if we work out this angle over here is the 57 degrees, take away the 15 degrees. So 57 take away 15, that's 42. So here we have 42 degrees. And if we were to draw out this triangle, we can find out the distance between A and B. So drawing out that triangle again, we've got here the point A, the point B, the point T, this angle of 42. We also have the 3250. So we've got 3250, and here we've got the 4960. So we've got 4960, and what we need to do is find out AB. And we can do this using the cosine rule. So AB squared equals 3250 squared plus 4960 squared minus 2 times by 3250 times 4960 times by the cosine of 42. So if we work this out, we've got 3250 squared plus 4960 squared minus 2 times by 3250 times by 4960 times by the cosine of 42. So therefore here we get a value of 112,05110.83, and therefore for AB we've got the square root of this, which is 3347.403, etc. And therefore the distance between A and B will be, well, if we round this to 3 significant figures, we have 3347. So we've got 3347 to 3 significant figures. Question number 18. A cone has radius r centimeters and height h centimeters. The height is 3 times the radius, and the volume of the cone is 2100 centimeters cubed. We have to calculate the radius of the cone, and we're given that the volume is a third pi r squared h. Well, if we have the height being 3 times the radius, then we can see then h is equal to 3r centimeters. Now we're told what the volume is, So we've got 2100 equals 1/3 times by pi times by r squared times by h, which is 3r. And so therefore, what we have is 2100 equaling, well, here the third and the 3 cancel, so we're left with pi r cubed, and therefore r is equal to 2100 over pi cube rooted. So if we work this out, we've got the cube root of 2100 over pi, which is 8.743, etc. So therefore, the radius is equal to 8.74 centimeters to 3 significant figures. Question number 19. The point -52 lies on the circumference of a circle with the center at the origin, and we have to find an equation of the circle. So you can see here we have a set of axes, okay, and if we draw a quick circle, here you can see our circle, and then we've got the point -5, 2, so that's over here somewhere. Let's just write this down. We've got -5, 2, and we have to find the equation of the circle. Well, what we need to do before we do anything else is find out the radius. So for us to find out the radius, of course, here we can use Pythagoras. We can essentially split this up into a right-angled triangle, like so. So therefore, we have the radius r, well, an equation of a circle that's given by x squared plus y squared equals r squared, assuming it passes through the origin. So we need to find out what r squared is. So here we've got a length of 5, here we've got a length of 2. So therefore we've got here r squared equals 5 squared plus 2 squared. So r squared is equal to 25 plus 4, which is 29. And therefore, the equation of the circle, we've got x squared plus y squared equals r squared, which is 29. And now for part B, we have to work out the gradient of the tangent to the circle at -5, 2. Well, the gradient of the tangent, what we need to do is find out the gradient of this line over here. Here is where we have the tangent. And what we should know, the tangent and the radius are perpendicular to each other. So let's begin by finding the gradient of the radius. We've got the change in y, so we've got the change in y being +2, of the change in x, which is -5. So the gradient of the radius is -2/5, and therefore the gradient of the tangent, that's equal to the negative reciprocal, so we've got -1 over the gradient of the radius, so we've got here the gradient of the tangent equaling +5 over 2. So we've got the radius here, the gradient of the tangent rather, equaling 5 over 2. Question number 20. We have to show that the equation x to the 4 minus x squared minus 9 equals 0 has a solution between x equals 1 and x equals 2. Well, first of all, because we have something equals 0, we will let that something equal f of x. So we will let f of x equal x to the 4 minus x squared minus 9. And if we work out what f of 1 is, we've got 1 to the 4 minus 1 squared minus 9, which is minus 9. So we've got 1 to the 4 minus 1 squared minus 9 equals -4, rather equals minus 9. And f of 2, that's equal to 2 to the 4 minus 2 squared minus 9. So we've got 2 to the 4 minus 2 squared minus 9, which is 3. So therefore, what you can see here is we have a change of sign. We're going from something negative to positive, and we see that f of x is continuous in between x equals 1 and x equals 2, and therefore we have a root alpha is in between 1 and 2. And now for part B, we have to find the solution giving the answer correct to 1 decimal place. Now, there are a couple of ways of doing this. One way is we can continuously find a change of sign, so we can continue finding smaller intervals. That's one way. The other way is to use iteration, and for that we'd have to rearrange so we've got x equals g of x essentially. And another way we can do this, and it's quite difficult to spot, is to recognize here we've got a hidden quadratic. That's because x squared squared is x to the 4. I'll explain what I mean by that. So far, we've got x to the 4 minus x squared minus 9 equals 0. And if I rewrite x squared as, if I rewrite x to the 4 as x squared squared, of course 2 times by 2 gives the 4, then we've got x squared squared minus x squared minus 9 equals 0. And at this point, you can make a substitution. So for example, you can let t equal x squared, and if we do that, we've got t squared minus t minus 9 equals 0. So now let's attempt to find out what t is. We can use the quadratic formula, and just as a reminder, here is the quadratic formula. So if we work out what t is equal to minus 1 plus minus 1 squared minus 4 lots of minus 1 lots of minus 9, and then this is square rooted, and then we divide by 2 lots of 1. So here we've got 4ac. So therefore, if we work this out, of course if you've got a class quiz you can just directly use your calculator. We've got 1t squared minus t minus 9. So therefore t is either equal to 3.541, etc. So let's store this into A. And for the other value, we've got minus 2.54, etc. Let's store this into B. Now because we said t is equal to x squared, we'd have x squared equaling 3.541, etc. Or we've got x squared equaling minus 2.54, etc. But the problem is here, x squared cannot equal this value. We can't square root a negative, so let's just write that down. So therefore, we have over here no real solutions because we can't square root a negative. And therefore, if we attempt to find out what x is, what we have then is, if we go back, we've got the square root of that value a. So we've got x equals plus minus 1.54. 881, etc. So what we have then are two correct solutions. To one decimal place, we've got x equals 1.9. And technically, we should have plus minus 1.9, as we saw here. Question number 21. Toy building bricks are available in two sizes, small or large. A small brick has volume 8 centimeters cubed and width 2.1 centimeters. A large brick has volume 15.625 centimeters cubed. We have to work out the width of the large brick. Well, what we can do is find the volume scale factor. The volume scale factor, well, here we've got the volume of the big shape, 15.625, divided by the volume of the small shape, 8. So therefore, we've got 15.625 divided by 8, which is 1.953125. And therefore, for the length scale factor, we have the cube root of 1.95, etc. So the cube root of this is equal to 1.25. So that's the length scale factor. And therefore, to work out the width of the large brick, we need to multiply the 2.1, which is the width of the small brick, by 1.25. And if we do this, timesing this by 2.1, we get 2.625 centimeters. So we've got 2.625 centimeters for the width.